Imagine this. You're standing in a busy city, first century AD. Everything's, normal, maybe a little tense, but normal. And then in just a moment, the world literally falls apart.
And we're not talking about just a bad thunderstorm here. This is a catastrophic disintegration of the entire environment.
Exactly. I mean, a storm rages for hours, earthquakes split the ground open, fires are breaking out all over the place, and then, this is the kicker, a thick, suffocating vapor of darkness just hangs in the air for 3 days.
Yeah, you can't light a torch. You can't even see your own hand.
It sounds like the climax of some disaster movie, or for a lot of people, just a really intense religious allegory.
Right. And that's the scene from 3 Nephi in the Book of Mormon.
For a long time, I think even believers might have read that and thought, okay, symbolic. The world is dark because it's sad. Got it. But today, we're doing something different. We are putting on our detective hats.
Oh, we are. We're not looking at theology today. We're looking at tectonic plates. We're talking volcanic ash, soil liquefaction, even engineering formulas.
We're asking the big question, is this just a scary story? Or does this description actually match a real-world, specific geologic event you can pinpoint on a map? And to do that, we're deep diving into a review by Neal Rappleye called The Great and Terrible Judgments of the Lord.
And that review is analyzing a book by Jerry D. Grover, Jr., Geology of the Book of Mormon.
It really feels like a forensic investigation. We're looking for a crime scene.
That's a perfect way to put it. It's a best fit analysis. If you take the text absolutely, literally, every fire, every sunken city, is there a place on Earth that actually behaves like that?
I love this kind of stuff. It's where science meets history. So where do we start? I mean, people have tried to figure this out before, right? This can't be a new idea.
Oh, definitely not. People have been talking about this for decades.
Yeah.
Back in the 60s, you had Hugh Nibley pointing out that the description, the thunder, the shaking, it sounded an awful lot like a volcano.
So he saw the general parallel. That smells like sulfur.
Basically, yeah. He said Central America is a perfect setup. And then in the 80s, you had John Sorenson and James Baer looking at Mesoamerica. By the 90s, a geologist named Bart Kowalis argued that a single massive volcanic eruption could explain almost everything.
That seems tidy, doesn't it? One volcano goes boom, you get the storm, the shaking, the darkness. Case closed.
You'd think so.
Yeah.
But this is where Jerry Grover comes in. He's a professional engineer and a geologist. He looked at that volcano-only idea, and he found a problem with the math.
The math, like the physics of it.
The seismic math. See, volcanoes do cause earthquakes, but they're usually, well, they're pretty weak. We're talking magnitude 3 or 4.
Which is, what, really? Like, is that going to knock down a city?
Not at all. A magnitude 4 is like a heavy truck rumbling past your house. It might rattle the dishes, but it's not going to flatten buildings. And crucially, that shaking is really localized, like only within a few kilometers of the volcano itself.
But the text describes devastation across the whole land. The whole face of the land was changed.
Precisely. You've got cities sinking, mountains burying other cities. Grover's point is that a standard volcanic eruption just does not pack enough punch to do that kind of widespread damage.
So the volcano-only theory is out. What's the alternative then?
He says you need a perfect storm. You need a major volcanic eruption that is triggered by or happens at the exact same time as a massive regional earthquake.
So not just a volcano and a megaquake.
A 1-2 punch. And not just any earthquake. You need a specific kind. A strike-slip fault.
Okay, you're going to have to break that down for me. What is a strike-slip fault?
Imagine 2 huge blocks of the Earth's crust sliding past each other horizontally, like rubbing your hands together, but on a continental scale. It creates these violent ruptures right on the surface.
And the text mentions a great noise. Is that related?
That's the key. Deep earthquakes are mostly just felt. But shallow strike-slip faults, they scream. It's rock grinding on rock. So now we have a geologic fingerprint. We're looking for a place with a big strike-slip fault that has a major active volcano sitting right on top of it.
That feels like a very specific thing to look for. Does a place like that even exist?
It does. It acts as a massive filter, and it points to one place, the Veracruz fault segment. It crosses the Isthmus of Tehuantepec in Mexico, and sitting right on it is the San Martín volcano.
And San Martín was active back then?
It has documented eruptions right in the 1st century AD range. It fits the timeline perfectly.
Okay, so the location fits. We have the engine for the disaster. But let's get into the CSI stuff, because this is what I found fascinating. The text mentions specific cities, and very different things happen to them.
This is where Grover's work goes from theory to, like you said, forensic analysis.
Right. It's not just everything got wrecked, some places burned, some sank, some got buried. Does the geology actually back that up?
It does. And he uses something called the Mercalli scale to show how.
Okay, remind me. We all know the Richter scale.
Richter scale measures the total energy of the quake at the source. One number. The Mercalli scale measures the intensity of the shaking at a specific spot on the ground.
So how bad it felt right where you were standing.
Exactly. And that intensity depends on two things: how far you are from the fault and what kind of soil you're standing on.
Soil makes that much of a difference.
They have a massive difference. Think of it like this. If you stand on a concrete slab and I hit it with a hammer, you feel a vibration. If you're standing on a big bowl of Jell-O and I hit it, you're going flying.
So bedrock is stable, soft soil is the Jell-O.
Right. And soft, wet soil amplifies the shaking, sometimes by a huge amount. So Grover took the standard geography model, the one from John Sorenson, and calculated the likely intensity for each city based on the actual soil maps.
And what did he find?
The results are startling. Let's start with Zarahemla.
The capital. The text says it took fire, it didn't sink, it wasn't buried, it burned.
Right. If Zarahemla is at the Santa Rosa site in Chiapas, it's a good distance from the fault. Grover calculates the shaking. There would have been a level 4 or 5 on the Mercalli scale.
Which means?
Strong enough to be scary, strong enough to knock stuff over, vases, furniture.
And oil lamps.
And oil lamps. Imagine a whole city lit by open flames. The ground shakes just hard enough to tip all of them over.
But not hard enough to knock down the buildings themselves.
Exactly. The buildings stand, but the contents catch fire. It fits the seismic profile perfectly.
Okay, that's one. What about the city of Moroni? It says it sunk into the depths of the sea. That always sounded so mythological.
Like Atlantis, right. But it's a very real geologic phenomenon. If Moroni is near the Mecocan Lagoon, the soil is totally different. It's loose, water-saturated sediment.
The Jell-O.
The Jell-O. Grover calculates the intensity there would jump from a level 5 all the way up to an 8.6.
Whoa! That's a huge jump.
It's catastrophic. And when you shake soil like that hard, you get liquefaction.
I've heard of that. The ground basically turns into soup.
That's a great way to put it. It loses all stiffness. Buildings just sink. Combine that with a tsunami from a coastal quake, and the city literally slides into the water and disappears. It's not magic. It's soil mechanics.
That is just terrifying. Okay, what about Morona? A great mountain covered it.
Another one that sounds biblical. In the Sorenson model, this city is in the Grijalva River Valley. That area is right near the high-intensity zone, and the terrain is steep. It's prime real estate for earthquake-induced landslides.
So the mountain wasn't a mountain falling from the sky, it was a landslide.
A massive landslide burying the city. So you have burning, sinking, and burying, all distinct fates explained by one event, just depending on where you were on the map.
And what about Bountiful? That's where the survivors gather, so it must have been safer.
Which is weird because on the map, Bountiful is actually closer to the volcano and the fault than Zarahemla was.
Wait, hold on. If you're closer to the epicenter, shouldn't it be worse?
Normally, yes, unless you're standing on solid bedrock. If Bountiful is near modern-day Tonala, it's on an incredibly stable rock formation. Grover points out that the bedrock would dampen the shaking. It would be the place with the least structural damage in the whole region.
So it becomes a logical refugee center. Everyone runs to the one place that's still standing.
Precisely. The geology actually dictates the narrative.
That is wild. Okay, I want to pivot to the 3 days of darkness, the vapor of darkness.
Right.
I've heard people argue, was it ash? Was it just clouds? What does the science say?
This is a big one. Some people say, oh, it's just earthquake dust. But Grover is firm on this. Dust settles in hours. It does not cause a 3-day blackout.
So it has to be volcanic.
It has to be volcanic ash or tephra. And here's the detail that's just stunning. The text is very specific. It says they could not light any fires, neither candles nor torches.
I always just figured that was metaphorical, or maybe it was too windy.
It's chemical. Dense volcanic ash clouds can actually inhibit combustion.
Wait, really? The air is too dirty to burn?
Essentially, yes. There's so much particulate matter and maybe displacement of oxygen by volcanic gases that a flame literally cannot sustain itself. You get a spark, but it just fizzles out.
That is an incredibly specific detail for someone to just invent.
It is. And the duration 3 days fits the dissipation rates for a huge tephra cloud. And Rappleye points out that the 1793 eruption of San Martín, the same volcano, produced an ash cloud that covered this exact region and turned day into night.
So we have a historical precedent from that exact spot.
We do. Okay, speaking of weird details that turn out to be science.
Yeah.
The source takes a detour to the Book of Ether.
Right. This is a different civilization, the Jaredites, but living in the same land centuries earlier.
Different people, same geology.
And there's this story in Ether 9 about a famine and then a plague of poisonous snakes.
Libel is serpents, yeah.
It just sounds so over the top, like snakes came and hedged up the way, a wall of snakes, come on.
That sounds fantastic.
Yeah.
But Grover looks this through an ecological lens. He connects it to something called a volcanic winter.
Okay, explain that. How does a volcano cause a snake plague?
So a big eruption throws sulfur and ash into the stratosphere. This reflects sunlight and cools the region down for a few years, causing a severe drought. But it also has this domino effect on the food chain.
The animal.
The cooling and the ash are devastating for birds. Now, who is the main predator of snakes?
Birds, eagles, hawk.
Exactly. So the volcano erupts, the bird population crashes, and suddenly the snake population has no predators. It just explodes.
I see where this is going.
But you also have the volcanic drought. So the snakes are overpopulated and they're desperate for water. So they migrate en masse toward inhabited areas where there might be rivers or wells.
Do they actually do that? Migrate in a huge group?
They do. Grover cites a real-world event in 2007 in Australia. A huge drought caused venomous brown snakes to invade cities like Sydney. They were everywhere, looking for water.
So you get a population boom from no predators and a forced migration from the drought.
And notice how the story ends. The snakes eventually stop being a barrier, Grover's theory. The bird populations recover, they start eating the snakes again, the ecosystem rebalances, and the plague ends. It's a biological chain reaction.
Wow. Okay, so this brings us back to the map. If the geology is this specific, this must rule out a lot of other theories about where the Book of Mormon took place.
It acts as a very strict gatekeeper. Grover says any viable model has to have an active volcano in the land northward and a fault system that can produce a level 8 quake. If you don't have those, you just can't explain the text.
So what does that do to the heartland theory, the idea that it all happened in the U.S.?
Geologically, it basically rules it out. There are no active volcanoes in the central or eastern U.S. You don't have the engine to create the 3 days of fire-suppressing darkness.
You had the New Madrid earthquake in 1811, though. That was huge.
It was. But it produced dust, not a vapor of darkness. The mechanism is wrong. Same goes for theories in Baja or Costa Rica, wrong geologic setup.
And what about even within Mesoamerica? Some models put the land southward in the Yucatan Peninsula, right?
The problem there, Grover says, is that the Yucatan is seismically quiet. It's a flat limestone shelf. You don't have the faults to create the prison collapse at Amanaiha or the Great Noise.
And bountiful in those models.
It often ends up right on a fault line, which would mean it gets destroyed, not saved. It completely flips the narrative.
So you'd have to invent a second event to make it work.
Exactly, and that violates Occam's razor. The simplest explanation is usually the right one. The Sorenson model, centered on Tehuantepec, it explains everything with one major event, one volcano, one fault system, one very bad day.
And what's so amazing is that Sorenson developed that model mostly using anthropology and geography, right? Not geology.
That's the real validation. He placed the cities based on travel times and terrain. Decades later, a geologist comes along, overlays the fault lines and soil maps, and finds that the cities are in the exact spots where the described destruction could actually happen.
It's like a blind test that passed with flying colors.
It is. It suggests the text is incredibly consistent with the physical reality of that one specific region.
So let's bring this all together. What's the big takeaway?
The takeaway is that 3 Nephi contains what you could call a geologic fingerprint. It's not a vague story. It's a highly technical description of a strike-slip earthquake triggering an explosive volcanic eruption.
And it turns the details people might mock. The snakes, the darkness. You can't light a fire into the strongest evidence.
Those are the details that demand a scientific explanation. I mean, you'd have to be unbelievably lucky in the 1820s to guess the combustion inhibiting properties of ash or the soil mechanics of liquefaction.
It moves the conversation from, is this possible, to this is probable, but only in this one specific place.
It anchors the story to the ground.
I want to leave our listeners with this thought. We've talked about plates and ash and soil, but think about the person who wrote this. If the geology is this precise down to the bedrock protecting one city while the soil swallows another, what does that imply about the source?
It raises the question. Did the writer just get incredibly lucky with their physics? Or are we reading an eyewitness account of a very specific and very bad day in the 1st century?
Something to think about. Thanks for diving in with us.
No pleasure.
We'll see you on the next deep dive.